Hi, this is Sri from TechieTalksAI. Welcome to this Arduino series. Remember, this series will continue till we build fully autonomous AI-based robotic systems. Now, this one is a simple, easy to do robotic car, which we call obstacle avoiding or obstacle seeking robotic car. Now, this is a multi-part series. It will take 3 to 4 days for us to finish. We have to go step by step. So first thing that we need is a mechanism to see the obstacles in front. For that, we will use this ultrasonic sensor. One is an ultrasonic transmitter, other is the receiver, which receives the signal, and the time difference between the send signal and the received signal, using which we can calculate the distance of the obstacle. So here on the screen, do you see the distance being printed on the serial monitor? The serial monitor, how it works, etc., we will see later. But if I now bring my hand close to this, you will notice that the reading is low. Distance is low. But if I remove my hand at some location, distance is more than a meter. See this? So using which, so you are more positioning the server. So you know which angle that distance is. So you can turn the robo or the robotic car to that direction. So first thing we need to build is the servo and the ultrasonic sensor. This will be fitted in front of the robotic car. And once this is functional like this, we can move on to the wheels and the motor drive, so that we can go straight, turn left, turn right, etc., depending on the location of the obstacle or the location of the free path. Okay, so now let's look at the code. So what I will do is I will keep this here. Okay, let it be there. Okay, okay, I will push it with like this. Okay, I will remove this and keep it so that it won't fall. Now the connection and the wiring we will see. This ultrasonic sensor has got ground, then echo, that is where it receives the signal, bounced signal back, and it has got a trigger. Okay, and then it has got VCC, which is +5. So since Arduino has only 2+5 points, it is better to use a breadboard to connect multiple plus points. But in this case, we need to connect the servo and the ultrasonic sensor both to the +5. So in this case, we don't actually need the breadboard, but we need to connect the motor, etc., in subsequent videos. So we will for now, we will use a breadboard. Okay, so this plus of the breadboard is connected to 5 volt of Arduino. Minus of the breadboard is connected to ground of the Arduino, and then this sensors ground and plus are connected accordingly. and trigger is connected to pin 9, and echo is connected to pin 10. So that is the connection. So here, see here, now there is no obstacle. You can see the reading, and now, okay. So that is the wiring of ultrasonic sensor. Then we have the servo. Servo has 3 wires: ground, VCC, and the signal. So servo is signal is connected to pin 6 here. Okay. And ground and +5 are connected to this breadboard bus. That is the connection. Now let's look at the code. Again, like before, we need to include the servo library, servo.h, and define the class called scanner. This scanner can be anything. Okay. So it can be obstacle underscore scanner, etc. Then here we are defining the pins. We are using 3 pins, 6, 9, and 10. In this project, there is no push button. After that, we are defining minimum angle 30 and 150. That is the range with which it will scan. We can even set it to 0 to 180 as well. Then this serial begin is for us to print the serial monitor output. Normally we don't need it. After we complete our project, we can comment these lines out. And this is where we are reading the distance. Okay, so here in this location, this this function will read the distance and return the distance. See here. So how it is doing is, it will write a low voltage or make the trigger low. Okay, sorry. See, the trigger is the input, trigger is the output from the sensor. Trigger will give the ultrasonic signal, and then it will wait for 2 microseconds. See this? So we make the trigger pin of the ultrasonic sensor low and wait for 2 microseconds. Then we will make trigger high. So what this does is, it'll produce a pulse of 2 microseconds. That is clear? A pulse that goes high to low for 2 microseconds. And then here we wait for 10 microseconds. And then again, we make trigger low. Okay, and then this pulse in is the method which is there, where we can give echo, pin, high pin, and time period. Okay, here we are giving 20,000. Now, here this calculates the distance. Okay, and then this function is returning the distance. Clear? And now, this is the loop where from the minimum angle to maximum angle, this oscillates. And it reads the distance. Okay, so we write the angle to the server. So server moves. So one angle, we read the distance. Then again server moves to next increment. That way, every 3 degrees we measure the distance. Every 3 degrees, server will move and measure the distance. So that is sweep left, and once it reaches the left endpoint, it will call the sweep right, and it will go on oscillating. That is it. So this is the first part of the obstacle avoiding or obstacle seeking robotic car. Okay. So let's reset it. So this is how the servo moves, and we connect the ultrasonic sensor there. Okay, so I have been tightened these things. When we mount these on our car's chassis, we will mount it. Okay, that is it for this live session. Thank you for your time. Bye bye. See you tomorrow when we build the motorized part of the chassis.